What I'm going to talk about this morning is Java. And it seems like a particularly auspicious day to be talking about Java. The reason being today is the big day, the release of JDK 11. Woo! Yes, let's wait and hold that excitement until I tell you what exciting new features you have in JDK 11. So what I'm going to talk about is really where we are with Java. So I've called this, JDK 9, 10, and 11. And clearly one of the things that we are seeing that's changing is how quickly we get releases of Java. So we'll talk about what's in JDK 9, we'll talk about what's in JDK 10, we'll talk about what's in JDK 11. And we'll also talk about how these changes impact what you're going to use in terms of JDKs moving forward and how you're going to deploy your applications, the choices you can make in terms of that. And then at the end, I'm also going to talk a little bit about some of the sort of longer term futures for Java, some of the bigger projects which are being developed to add more significant new features. So lots of information to get through, lots of stuff to tell you about. So to start with, let's talk a little bit about JDK 9, because it was literally a year ago that JDK 9 was released. And I borrowed this slide from Oracle. I used to work for Oracle, and I figure I can borrow some of their slides still. And what it does is it shows you all the features which went into JDK 9. And I think if you count them up, there's about 86 that went into JDK 9. A lot of them were very small. A lot of them were quite low level in terms of the JVM and so on. But there were some which were more significant and things that you could use and help you to develop code and so on. But of course, the big one for JDK 9 was the introduction of modularity. Now, I don't want to spend too long talking about modularity, but it is important, and so I've got a couple of slides where I just want to make a few points about this to help you understand some of the things that you need to know in terms of when you migrate your applications to JDK 9 or JDK 10, or more importantly, JDK 11. Because obviously, all of the releases since JDK 9 also have modularity. All of the things you need to consider from the point of view of modularity, you will also have to consider when you move to JDK 11. What is modularity? Well, in its simplest form, what the developers did was they said, we have rt.jar, and it's got very big. If you go right back to the beginning of history of Java, in JDK 1.0, anybody here use JDK 1.0? Okay, a few people, good, a few people there. So there were about 200 classes, 211 I think it was, in the standard class libraries at that point. If you move forward to JDK 8, what you'll find is 1,500 classes in rt.jar. And that's really good, because it means we don't have to write our own list interface, we don't have to write our own semaphore class, we don't have to write all these different things because they're already there. So lots of functionality has been added, and we can make use of that to develop our code more quickly. Problem is that it's become monolithic, and all of these 4,500 classes are in one file. Nobody, I'm sure there's nobody who would actually use all 4,500 of those classes in a single application. I just can't imagine what an application would be if it used all of those classes. So what we really needed to do was to break up rt.jar into more manageable pieces, and that's what modules are. The developers went through a lot of work on this, and they came up with, if you look at the OpenJDK, 75 modules. There's a few more in the Oracle JDK, but in the core OpenJDK, there's 75 modules. 27 of those are for Java SE. That's the standard which defines Java, and it's the minimum set of things that you need in order to call your platform Java. So there's 27 for that. Then there's 48 which are part of the JDK. And that's all sorts of different things, like there's JShell there, there's Nashorn is there, unsupported is there. There's all sorts of different modules there as well. Like I say, the Oracle JDK has a few extra ones. It's got JavaFX, it's got a couple of Oracle-specific ones, and so on. But the idea is that by breaking up the rt.jar into more manageable pieces, what you can then do is build a runtime which is tailored specifically to your application. And you can minimize the size of your runtime to only have the modules that you need. The other side of modularity, the thing that's actually a bit more of a concern when you're moving applications, is that the developers wanted to encapsulate all of the internal APIs. 4,500 classes in rt.jar which are public, but then there's a whole set of other classes which are there to make those 4,500 public ones work. These were never intended to be used by developers. And right from the very beginning, Sun and then Oracle have always said, you know, these internal APIs are not to be used by developers. They didn't document them, they didn't tell you what they were, they didn't provide any tutorials and so on these. And the most famous or infamous of these is sunmisc unsafe. So who here has used sunmisc unsafe in their code? Okay, good, right, a few people. Anybody here use a third-party framework or library, something like Spring, for example? Yes, right, so you have used sunmisc unsafe, you just don't know it, because a lot of these frameworks and libraries, in order to improve the performance, in order to get low-level functionality, the developers use these things. What the Oracle developers wanted to do was to encapsulate those, which means that they would completely go away. And a lot of people said, ooh, no, that's not going to work because we've used them. And it would break all of the code that we've written. There's no easy way of replacing them. So you just can't do that. So they did kind of backtrack on that a bit. And they said, OK, we'll give you some command line flags which allow you to turn on things like reflective access to certain APIs. And you can turn off the encapsulation completely if you want to. So there are ways of getting around this. So that's kind of the two big things in terms of modularity. As I said, one of the key advantages of modularity is this ability to build a runtime just for your application. And really, one of the kind of key areas where that makes a lot of sense is microservices. You know, what you can do is you can build a Java runtime with your microservice code, and then you can put it all in a container, ship that container, and because it only contains the modules you need, it's a lot smaller than it would be if you had the entire Java runtime in there. Realistically, a full Java runtime can be several hundred megabytes. By using jlink, which I'll talk about in a moment, you can actually shrink that down in terms of the very minimal set is kind of around 10 megabytes. So even if you add a few modules that you need for a particular microservice, you really can reduce the size quite dramatically. Jlink is the tool that you use to do that. So what you do is you say, okay, I want to create a runtime. I use jlink. I tell jlink where my modules are. And in this example, what I'm going to do is just put the Java base module in there. You have to have Java base because it's essentially like the object of modules. Everything depends on Java base. So we're going to put Java base in there, so we'll add that module, and then we'll tell jlink where we want to put the runtime. And that's a directory where it will build the structure that we're going to use. When you run that, you will find a directory structure that looks exactly like the JDK. Almost. There's one slight difference, but I won't go into that. So you've got a bin directory, you've got a lib directory, you've got a conf directory, and so on. And what you can then do is you can go into that directory, and if you run the Java executable in the bin directory, and you say list modules, it will give you back the fact that it's only got Java base. Okay, so that's not very much use unless you want to do something like printf hello world. Let's look at a slightly more realistic example. In this case, what I'm going to do is I'm going to take an application I wrote, and I'm going to create a runtime for that. So I'll do the same thing. I'll jlink, tell it where the modules are. Obviously, I've got the JDK modules and my modules. I'm going to add just my zap module because the jlink command using the compiler will figure out all of the dependencies for me. I don't have to list them all out myself. I just say, here's the main module, find all the dependencies and put those into the runtime. And again, where I'm going to output things. If I run the Java command in that directory, what I see now is I've got Java base, Java logging, SQL, XML, and then I've got the modules I need for my application, Zap, Zoop, and Zeta. All of the dependencies have been worked out for me, and I've got a nice compact runtime that I could deploy for my application, maybe into a container, however I want to do it, but it's a much better way of doing things. So this is a really good part of JDK 9. Now let's talk a little bit about moving Java forward faster. When JDK 9 came out last year, Oracle made a number of announcements about how they wanted to change the development of Java. And this is the kind of catchphrase that they decided to use for this, moving Java forward faster. Good stuff. What does this mean? Right. Well, the first thing we need to say is that the development of the Java platform has typically taken quite a long time. You know, we've got sort of 23 years of history now. And I did a little sort of research on this, and going way back to sort of JDK 5, or JDK 6. JDK 6 came out 2 years and 2 months after JDK 5. JDK 7 was 4 years and 8 months after JDK 6. Now, to be fair, there were a few things that kind of got in the way of delivering JDK 7. The acquisition of Sun by Oracle, there were some discussions around Apache Harmony, there were some issues around the whole JCP and getting things moving that way. So it's not a technical problem that resulted in 4.5 years between releases. There were some other things as well, but that was what it was. And then JDK 8 came out 2.5 years, a bit over 2.5 years from JDK 7, and finally JDK 9 was 3.5 years from JDK 8. So what we're dealing with here is multi-year release cycles. Okay. The other thing about Java is we have this wonderful ability to be able to migrate to new applications in a comfortable way. What do I mean by that? Well, again, if you go back to when JDK 6 was launched, there were actually updates, public updates to JDK 5 for nearly 3 years after JDK 6 was launched. That meant if you were using JDK 5, you could carry on for nearly 3 years before you needed to move to JDK 6, or probably even JDK 7 by that time. No, it wasn't. No, JDK 6. So you had nearly 3 years of public updates enabling you to migrate to the next version at your pace. So it's nice and comfortable. If we look at JDK 7, there were updates to JDK 6 for just over 1.5 years after JDK 7 was released. So still plenty of time to migrate your application and make sure everything works. Even with JDK 8, there was over 1 year of updates after JDK 8 was launched for JDK 7. So we had a situation where everything was nice in terms of migrating our applications. We had time to do that. The other thing that's really nice about this is it allows us to be confident about the stability of the platform. Because when big new features are introduced, things like lambda expressions and streams, which are big pieces of functionality, and they are tested very well, but there might still be some things that need to be ironed out over time. What most people do is they wait a couple of updates before they move to the next release. So they make sure that everything's been sort of tested and people have tried it in the real world, and then they know what the issues are. So this is very good. So if we look at how we could describe the Java platform today, we can use 3 words. We can say that it's stable. And by that I mean that when you move from one version of the platform to the next, it's actually, you have a lot of confidence about how easy it is to move your application without having to make changes. Backwards compatibility has always been a real concern for Sun and then Oracle. The last thing you want to do is have to take a working application and then change it to make it work on a new version of the platform, because that's just kind of wasting time. Fair enough, there have been a couple of times when that hasn't quite worked out. The introduction of assertions in 1.4, the introduction of enumerations in Java SE 5 meant that certain variable names became reserved words, and you might have to go through and do a little bit of editing of your code. But they weren't big issues on the whole. So stability has been something we've been used to. Next thing is that we're confident in terms of Java being secure. Now, I know you can argue that a few years ago there were a number of kind of security issues that came up and had to be addressed. But what I mean by this is that every 3 months there is an update to the Java platform. And anything which needs to be addressed in terms of security may not be the JVM or the JDK itself. This could be something like Meltdown or Spectre, which is a security issue at a lower level that needs support to solve it from the JVM level. We know that every 3 months we're going to get some bug fixes, some security patches, which enable us to be confident that as far as possible, security issues are addressed. So we can say it's secure. And of course, the other thing that we can say about Java is it's free. You know, you go to java.oracle.com, you can download the JDK, you can use it, you don't have to pay anybody to use it, you can get your updates from there, you can use those, everything is great. So stable, secure, and free. Oracle have decided on a new release model. And again, they announced this same time as JDK 9 came out last year. What they said is that rather than waiting 2, 3, 4 years between releases, they're going to make it faster. So the idea now is every 6 months, we get a new major version of the JDK. We've already seen this because in March, we got JDK 10, and today, we will get JDK 11. So there's 2 releases, in fact, 3 releases in the space of a year. It's amazing, isn't it? You know, you wait for a bus and then they all come together. So JDK 10, JDK 11 are examples of how this is actually working. The idea behind this was to make the development of the Java platform itself more agile. This is the kind of approach that we use for developing software today. You know, we moved away from the waterfall style of doing things. Agile methodologies allow us to react more quickly to changes in requirements. It allows us to deliver new features more quickly in a more iterative way. So that's what they wanted to do. So rather than having a target of 2 years between releases, which, let's face it, they never did, they wanted to go for 6 months. The way that that would work is by changing the way that features get added to the JDK. In the past, what would happen is a set of features would be planned for a particular JDK. Only when all those features were ready would the JDK actually get shipped. And we saw with JDK 9, good example with modularity, there were some delays because various things needed to be changed. There were some objections to how things worked. So we actually ended up with 3.5 years between JDK 8 and JDK 9. With the new way of doing things, rather than planning a set of features for a particular release, what we'll do is we'll simply say, okay, at this point, we're going to freeze what we have. Any feature that is ready goes into that JDK. Anything that's not quite ready gets delayed to the next release or the release after or whenever it actually is ready. And that's realistic because now that we only have to wait 6 months for the next release, it means we're not having to wait years for even small features to be ready. So it is a good system. It means quicker access to more features. We can develop the platform in a better way. So this is all good. Now, Oracle have then said that for this kind of release model, they can't offer long-term support for all releases. It just isn't practical because very quickly you're going to end up with a large number of major releases that would need support. To get around that, they've said that they're going to adopt the same approach that people like Ubuntu have. Certain releases will be classified as long-term support releases, and the others will be what they call feature releases. And only the long-term support releases will have long-term support, quite logically. There will be a new long-term support release every 3 years. JDK 8 has been classified as a long-term support release. They needed to kind of get things started, so when they came out with this idea, they said, okay, everybody pretty much is using JDK 8. Some people are using older ones, but a lot of people are using JDK 8. So we'll make that the first long-term support release, and we'll keep issuing updates to that. They're going to keep issuing public updates until January of next year. At that point, public updates for commercial users will stop. If you're a non-commercial user, then you'll continue to get updates through the auto-updater until the end of 2020. What I mean by non-commercial users is if you're sitting at home playing Minecraft, then you will get updates. If you're running Netflix or whatever, then you won't get updates for free. The next release is today, JDK 11. As I said, JDK 9, JDK 10 are feature releases, and what that means is that the updates you get for those are only going to be 2 scheduled updates. So there's an update every 3 months. In the case of JDK 9, JDK 10, there were 2 updates, and both of those have been released. There will be no more updates for either 9 or 10. So we're moving to 11 now. Another thing that Oracle have decided to do is to change the way that they provide binaries of the JDK. Now, what we're used to at the moment, or in the past, is that if you want to get Java, you go to java.oracle.com, and there is a binary that you can download. There's a license associated with that, which is called the Oracle Binary Code License for Java SE. It's a little tick box that you have to accept the license. I don't know about you, but I've never actually read the license, so I don't know actually what I'm accepting. But I do know that it has certain field of use restrictions. If you want to use the Oracle JDK, then you can use it on a desktop, you can use it on a server without any issue. If you wanted to use it in a single purpose device, like a kiosk, if you wanted to use it in an embedded device, then you would need a different license. You would need to negotiate with Oracle about that. Since JDK 9, Oracle have started to produce a second binary distribution. And this is one that's based purely on the source code of the OpenJDK project. If you go to jdk.java.net, you will find a series of links, and you can download this binary from there. This is under a different license. It uses the same license that you have for the the OpenJDK source code. So it's the GPL v2 with class path exception license. This has no restrictions in the sense of field of use. So you can use it in embedded, you can use it for single-purpose machines and so on. The key thing with these binaries is that all of them will only have updates for 6 months. There is no concept of long-term support for the OpenJDK binaries that Oracle are producing. So there's 2 scheduled updates for each one, and most importantly, there's no overlap of updates. So you don't get updates for 9 or 10 whilst the next releases come out. You have to just basically say, okay, when 11 comes out, that's it for updates to 10. To kind of eliminate differences between these 2 binaries, Oracle are also producing converged binaries. And what do I mean by that? So I've produced this Venn diagram to explain the sort of feature set. Java SE, as I said, is the standard defined through the JCP as a JSR. The minimum requirements that you need in order to call something Java. That's the VM spec, it's the language spec, it's the core class libraries. OpenJDK is the source code to the reference implementation of the Java SE standard. So it includes everything that is in that standard. But it's actually a superset of that standard. There are few things in OpenJDK which are not part of Java SE. Most obvious of these is the Nashorn scripting engine. So that's part of OpenJDK, but not Java SE. Then you've got the Oracle JDK, which is a superset of the OpenJDK. They include various other, some of them are commercial features, some of them are just additional features. But there's lots of extra stuff that was in the Oracle JDK that's not part of the OpenJDK and not part of Java SE. Moving forward, what we're now going to see is eliminating the differences between the Oracle JDK and the OpenJDK. So all the things that we had different before are going to be eliminated. Now there'll just be 2 circles in our Venn diagram, Java SE, and a superset of that, which is OpenJDK and therefore the Oracle JDK that's built based on that. So that's JDK 11 and later. In order to do that, Oracle have done 2 things. The first is they have contributed a number of features that were in the Oracle JDK as commercial features to the OpenJDK project. So they've now become open sourced. The most notable and obvious of those are flight recorder and mission control. These are tools that you can use to monitor your JVM. They're very nice tools. You can get lots of information. And now they're free, open source. There's a few other things like application class data sharing and little bits and pieces like that. But all these things have been contributed as open source to OpenJDK. The other thing they've done is to remove certain things from the Oracle JDK. And several notable things here. One is the browser plugin. So applet support is now gone from JDK 11. Similarly, Java Web Start has gone from JDK 11. If you're using Java Web, anybody using Java Web Start? Yeah, see a couple of people. Unfortunately, Java Web Start is being removed from JDK 11. It is still closed source. There is no open source alternative to that. There are some other projects that do similar things, but it is something you will have to consider if you're moving from JDK 8 or earlier to JDK 11. JavaFX is also being removed as a library. This one's less of an issue because there's a separate OpenJFX project under the OpenJDK sort of umbrella, and people are doing binaries that you can simply download, and it's quite simple to add JavaFX to JDK 11 and make it all work. Java Web Start browser plugin, there is no easy alternative to that. Compatibility. This is a change as well. What Oracle say, and this is a quote from Oracle's product management, clean applications that just depend on Java SE should just work. Don't know about you, but that's not quite as kind of reassuring as I would like. I would like to see will just work, but they should just work. And there are a number of reasons for this. And it's quite important to understand this, that compatibility moving forward is not quite the same as it was in the past. So JDK 9 started a cleanup of the JDK. Obviously, with the idea of breaking things up into modules was a great idea, but the other thing that the developers said was, like, we've got 23 years of technical debt in the JDK. There's lots of things that have been added, nothing's ever been removed. So we need to start doing some housekeeping. And what they did was they finally removed some deprecated APIs. If you go back and look at the APIs that have been deprecated, I think there's somewhere around 400 that were deprecated in JDK 8, but none had ever been removed. JDK 9, they had a massive clear up and they removed 6 whole methods. And you think, okay, what did those 6 methods do that was so bad that meant they were the ones that got removed? And it turns out that if you look at the problems you have in terms of actually splitting up the rt.jar into a set of modules, you end up with some very odd relationships because people have used all the available APIs in the library to build new APIs. For example, there's a link between JAX-WS, the web services side of things, and the desktop module. So if you want to run web services, you actually need the desktop module as well. So removing these 6 methods was actually part of the reason was to simplify modularity. JDK 10 took that a little bit further. They removed an entire package, 6 classes, 9 methods in 1 field. So they're starting to do a little bit of cleaning up. They also removed a whole bunch of redundant features from JDK 9, things like the JHAT tool, the Java Virtual Machine Tools interface, hprof agent, and a whole set of deprecated garbage collection options, things like incremental concurrent mark sweep just disappeared. And they tidied up some of the -XX options. JDK 9 removed 187 -XX options. And you think to yourself, if they could remove 187 and still have plenty left, it gives you an idea of how many of these options there are. JDK 10 removed another 36. I can't actually remember how many JDK 11 has removed as well. I don't think it's that many. So the housekeeping is going to continue. I already said that in terms of the JDK, applets, browser plugin, WebStart, JavaFX, all of those have gone away. But there's more, quite significant. Because we now have modules, we can start sort of removing bits of the standard API fairly easily. So there is this aggregator module, which is called java.se.ee, and it's kind of like a bizarre EE-SE module. That includes 6 modules. So there's Corba, there's the activation framework that's part of the Java Beans way of doing things, there's JAX-B, XML binding, and there's also web services in the form of JAX-WS, which is the SOAP-based web services. Anybody here still using Corba? No, okay, that's good, so we don't have a problem with that. Anybody here still using SOAP-based web services? Yes. See, this is something I find in all the presentations I do. Pretty much nobody's using Corba, but there are still some people using SOAP-based web services. So this is something you need to consider in moving to JDK 11. This module has gone away. They've completely removed all these 6 modules, so if you're using web services, you will need to provide the libraries as a separate module from somewhere else, so things like Maven Central or the reference implementation. Other things are planned for removal. This is not going to stop anytime soon. So Nashorn was deprecated in JDK 11, which means that the JavaScript engine is going away. Personally, I'm not too upset by that. You know, it's a JavaScript, Java. I know they got the same word in them, but you know, Java is to JavaScript as car is to carpet. Anyway, the CMS garbage collector has been deprecated as well, so at some point that may well be removed. The developers have said, well, we've got G1, and that's very similar to CMS, so why do we have to maintain both of them? And there's some logic to that, but a lot of people are saying, well, you know, G1 does a lot of good things, but we still get better performance in certain situations with CMS. How that works out in future, we'll have to wait and see. So the key thing now is that compatibility is not guaranteed. Whereas before, we were pretty safe that we could move our application from JDK 6 to JDK 7 or JDK 7 to JDK 8 without having to make any changes. Now we need to be more careful. Oracle have actually said that future versions of Java may include breaking changes. They've also said that anything that they're going to remove will be deprecated first. So you'll get some warning about the fact that a feature is going to be removed. And they very generously said they will give you a minimum of 1 release warning, which is good because if they gave you less than 1 release warning, it would be no warning at all. So you get them back, you could potentially only get 6 months warning of a feature going away. And you have to think to yourself, okay, can I deal with that? Do I need to think about how to deploy my application? Do I need to think about whether I'm going to use that version of the JDK and so on? Now let's eliminate some confusion, because I've spoken to a lot of people about this, and they've heard what Oracle have said about the changes they're making, but they haven't always understood exactly what the impact of that is and what the reality of that is. So, Oracle have said, I've said, there will be a long-term support release every 3 years. That does not mean that there will be 3 years of free public updates. So long-term support release doesn't mean long-term support release in terms of free public updates. As of today, with the JDK 11 being released, Oracle have said that the fact they now have 2 binaries, the Oracle JDK, the one that we're all used to downloading from java.oracle.com, will now still be free to download, but you will be able to use it for development. You will be able to use it for testing, you'll be able to use it for demonstrations, proof of concepts. If you want to deploy it into production, you will need a Java SE subscription, which is something that you have to pay money for. And that way you will then get updates from Oracle for that. So JDK 11, the Oracle JDK binary, is a long-term support release which you will need to pay for to use in production. The only free JDK from Oracle will be the one that they produce from the OpenJDK source code. So functionally, there's no difference. OpenJDK, Oracle JDK have now the same functionality, but different licensing and different availability of updates. Because remember that the OpenJDK binaries only have 2 updates. They only have updates until the next release of the JDK. What this means, very important, is that if you want to continue to use the JDK for free currently, then what you will need to do is to move to the next JDK every 6 months. Because that way you can get the next set of security patches and bug fixes, and then you get the 2 updates, and then you have to move to the next one. Remember that there's issues around backwards compatibility. Are you able to move your application to a new version of the JDK every 6 months? Something to consider. The other thing that some people have got confused about is, can they continue to use JDK 8? And the answer is yes. You can use JDK 8 indefinitely for free. So there's no problem with that. The license hasn't changed for JDK 8. Same with JDK 7, JDK 6. If you want to use any of the older versions, those are still available completely for free. But as of January next year, you will not be getting any more public updates to the commercial version of JDK 8. So as of January next year, you have to think to yourself, am I going to continue using JDK 8, or do I need to move to a newer release? So going back to what I said earlier, we have three words that we can use to describe Java: stable, secure, and free. That is still the case. But there is a bit of a change, because now you need to choose 2 out of 3. I'm glad you're laughing. What do I mean by that? Well, if you want to have stable and free, then you're potentially sacrificing security, because let's say you want to carry on using JDK 8 past January next year. You've got the stability of JDK 8, you know your application runs on that, you don't have to pay anybody any money. But you're not getting security patches for free, so you're sacrificing the ability to make sure that you are secure. If you want secure and free, you can do that, because you can say, right, I'm going to move to the new JDK every 6 months. That way, I'm continuing to get the JDK for free, I'm continuing to get the latest security patches, but you're sacrificing stability, because remember, backwards compatibility is not guaranteed, and there may be breaking changes. If you want stable and secure, you can have those, but you're going to sacrifice free, because, as Oracle have said, if you want the updates long-term for JDK 8 or JDK 11, then you need a commercial license, which you will have to pay for. So this is something of a change in terms of how we use Java. Now, I'm being a little bit unfair here in terms of, I'm not trying to worry you, but there are other things happening. So there are some things around the update projects. There was a post from Red Hat last night about how they are committing to doing backporting of fixes. There's the Adopt OpenJDK project, which Azul actually sponsor, who are doing builds of OpenJDK. So it's not quite as bad as you might think. There are some things going on to help provide updates and so on. So let's go back to the technical side of things. JDK 10. What do we get in JDK 10? Okay, so the most obvious developer feature in JDK 10 is local variable type inference. Great, we no longer have to explicitly define the type of a variable, a local variable. We can just use var. Other languages have had this for a long time, and now Java has it. So we can do something like this, where we can say, okay, var list equals a new array list of type string, and the compiler, very surprisingly, will infer that the type of list is an array list of type string. Great. If we ask that list for a stream, we get back a stream, and the compiler can again infer for us that it's a stream of type string. Local variable type inference is something which it can be abused. It's a feature that you can use in a very good way, and there's also places where you can use it in not such a good way. So some style guidelines have been provided to try and help you to understand where to use it and where not to use it. So there's things like, good idea is to use descriptive variable names. We all do that, don't we? Because it's just the way we write code. So var string list obviously indicates that it's a list of strings, and that's very simple. One thing I would say is that var is actually a reserved type, not a reserved word. What does that mean? Well, it means you can do var, and that will work quite happily. I wouldn't recommend it. And then you can do things like this as well, so you need to be a little bit careful, because the type inference can sort of work in 2 ways. So you can have type inference of the local variable, but then you also have inference of the generic type. So in this case, I'm creating a new priority queue using the diamond operator. But because I'm using var, the compiler has to infer from that I'm getting a priority queue of type object, because that's the only thing it can infer. If you wanted something different, then you would have to use something other than var. There are lots of other JEPs in JDK 10. I won't spend too long going over all of these, because, again, some of them are fairly small changes. The G1 collector, some people were complaining about the performance of G1 compared to the parallel collector. So now the full GC part of G1 actually is done in parallel rather than using a single threaded approach. So that's a good thing. Application class data sharing is a nice feature. That's one of the things I said was previously a commercial feature in the Oracle JDK. What that does is it allows you to start your application up, and when the JVM starts, it has to load all the classes that you need, and then it has to build some internal data structures. Application class data sharing will allow you to do that and then say, okay, dump those data structures into a file. When you start the JVM up again, rather than the JVM having to read all the classes and build those data structures, it just maps that file into memory and it's got the data structures ready to go straight away and improves startup time. Good for things like microservices. Also means that if you've got multiple JVMs running the same application, you can share that file memory mapped between JVMs, it's read-only, so you actually get better performance that way as well. There is an experimental-based JIT compiler called Graal. I'll come back to that when I talk about some of the bigger features later on, but it's just a different way of doing JITs. Root certificates is some of the tidying up of differences between the Oracle JDK and OpenJDK, and consolidating 8 repos into one just to tidy up the way that the JDK was built. A few other things, heap allocation on alternate devices. This is something from Intel so that you can use non-volatile RAM or DRAM for your heap space, and you can configure it how you want to do that. The Java H tool, that's another cleanup thing that's being done, so that's gone away. There's a Java C-H option now that does the same thing. Red Hat contributed a garbage collector interface. Now that's not an interface that you use from the application code to the garbage collector. It's an interface within the JVM. So that if you want to install a new garbage collector, there's a nice clean interface to be able to do that. Red Hat are working on a project called Shenandoah, so that's kind of related to that. It's good for us at Azul as well because we have Zing and we have C4, so we can now move that to different versions of the JDK in a simpler way. And then there's this very low-level thread local handshake, which is about improving performance when you're trying to pause a single thread and not having all threads reach a global safe point in order to do that. 73 new APIs I counted up in JDK 10. Several of these are around the idea of immutable or unmodifiable collections. So list, set, and map all have a copy of method now, which takes a collection and returns an unmodifiable collection, equivalent of that collection. Related to that is the idea of the collectors for the streams API, and there are 3 new collectors which will generate a collection which is unmodifiable from your stream. And just one other that I put up here was optional or else throw, which is pretty much the same as get. But it is exactly the same as get, so I don't know quite why they put that in there, but they did. A few miscellaneous things in JDK 10. This is quite funny because they deprecated the new factory method of XML input factory, and then they decided they made a mistake, so they had to de-deprecate, or is it precate, or is it undeprecate? Not quite sure, but anyway, they removed the deprecation tag from that. They removed some more packages and so on, and classes, as I said. Most important thing really is that the JVM is now more Docker aware, so your container. One of the problems you had before was the idea that the JVM would look at the resources of the machine, not of the container. And so potentially it would set the heap to be too big, it would set the number of threads for the fork join pool to be too big as well. That's been fixed. JDK 11, so this is what we get today. Right. This has 17 JEPs, JDK enhancement proposals. And one of the nice things is we're seeing more JEPs coming from outside Oracle. Azul were actually the first company to submit a JEP that was accepted into JDK 9. We had 3 in JDK 10, and we've got 3 from outside of Oracle in JDK 11. So there's the Epsilon garbage collector, improved intrinsics for the ARM64 architecture, and low overhead heap profiling. That one came from Google, which is great because Google are back into Java again. Okay, dynamic class file constants. These are things that, from a developer point of view, don't really make any difference to you. It's like invoke dynamic, but for class file constants. Certainly when I looked at this, I thought, hang on, dynamic constants, that doesn't make any sense, because it's either dynamic or it's constant. It can't be both. But it can, because you can think of it like a final in Java. A final means that you can set the value once, but you can't then change it. So it is constant, but it's dynamic in the sense that you can set it once. This is the same thing for class file constants. It uses the same approach as invoke dynamic. So it's a low-level JVM thing, which is designed more for people who are creating languages other than Java that are going to be compiled into bytecodes, and it makes life easier for them. So, as I say, it's kind of an interesting thing, and it's quite interesting to look at. The Epsilon garbage collector, a new garbage collector that collects no garbage. Kind of, okay, why would you do that? Actually, there's two reasons. The two reasons are, one, primarily for testing. This came from Red Hat. It's the idea that you run your application with no garbage collection happening at all, and then you build a sort of baseline for your performance. Then you put your new garbage collector in, and you run the same application, and you monitor the performance, and you see what the delta is, so you know the impact that your garbage collector is having on that. There's also, if you're doing very short-lived applications, it could be useful. So if you think about, serverless computing, lambdas on AWS and so on, then this could be something that would be useful to do that, because you don't get any impact from garbage collection. HTTP client, this was introduced in JDK 9 as an incubator module. And it's the idea that support for HTTP 2, an incubator module was the idea that rather than putting an API straight into the standard, give it to people, let them try it out, see if there's any changes that they need made, and then when they're happy with it, make it part of the standard, so you don't have the problem of trying to change it later on. That's what's happened here. It's now settled down, people are happy with it. So you've got a module called java.net.http and a package as well. There's essentially four sort of significant classes in here: HTTP client, HTTP request, HTTP response, and WebSocket. So you can do various things with that. It works in both synchronous and asynchronous mode. If you're using the asynchronous mode, then you're going to be getting into completable futures and completion stages in order to do what you need to do asynchronously. Extending local variable syntax. So this is kind of interesting. We had local variable syntax in JDK 10. So this is local variable inference. They've extended that to work with lambda expressions. So what we can do is we can say, okay, we have a piece of code here where we've got a map that has a lambda expression. And what we could do is we can rewrite that with using var. So we can do it this way. So we can say var s to lowercase. And you look at that and you go, well, why would I want to do that? Because lambda expressions already have type inference. Why do I just want to add the var keyword for the sake of it? And the answer is there's one particular place where this makes sense, which is if you want to add an annotation. Because if you want to add an annotation, you can't add an annotation without a type being specified there. So var just lets you use type inference without having to then use the explicit type. So again, it's just a small change which makes life a little bit easier. Unicode 10 support. Right, so Unicode has been updated since the last release of Java, so Java now supports the new version of Unicode. And I always like looking at this because they found 8,518 new characters to include in Unicode. And you think, how? How did they find that many characters? And it turns out that we now have a Bitcoin symbol. Yay, that's worth a lot of money. We have the Nishu character set. So I looked this up. Nishu is a character set that's used by Chinese women to write poetry. Not making it up. And then we also have Soyombo and Zanabazar Square. These are character sets that are used by Tibetan monks. Good to know. And then we have apparently the long-awaited Colbert emoji. So wonderful. The one thing I would say about this is if you look at JDK 9, JDK 9 introduced support in property files for UTF-8. That means you can use Unicode in property files, which means you can use the Colbert emoji, or you can use Nishu in your property files, should you want to. Launch single file source code. This is an interesting idea. And one of the problems that Java has is, well, I'd say one of the things that Java is sometimes criticized for is how easy it is to get started with it. Because if you look at scripting languages, if you want to do something very, very simple, you just write a little script and then you execute it. And with Java, you've got to create a class, you've got to do public static void main, you've got to do blah, 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 blah. And then you've got to compile it, and then you run it. So this is designed to make life a little bit easier. What you can now do is you can simply take a Java source code file, as long as it's only one, as long as you don't need multiple files, then you can just say Java, in this case factorial.java, and it will run that. So it will say, okay, that's a Java file, I'll compile it, then I'll run it. So you don't have to do anything extra, and you can just say Java factorial.java, and you can specify parameters, so in this case 4, and that will get passed to the executable. There's lots of other things in terms of how you can set the class path and so on and things like that. You can also go a little bit further. So there is Shebang support in this, which means that you don't even need to use the Java executable on the command line. What you can do is you can actually put the Shebang line at the start of your source code file, and in this case you can say hashbang java home bin java. You've got to specify the ---- source parameter with which version you want to use, which is currently 11, and then you've got your code, and if you do /factorial, assuming you've set execute permission on that, you will get the output printed because it will actually all work. So you don't even need to reference Java on the command line anymore. So this is quite a nice little feature, I think. Lots of other JEPs that have gone into JDK 11. I'm not going to go through all of these because some of these are quite kind of low level. So improved intrinsics, as I said, this is improving the way the compiler generates code for ARM64. There's a number of things around security, updates to some of the algorithms that are used to replace elliptic curve Diffie-Hellman algorithms with these various things. Low overhead heap profiling is the thing that was contributed by Google so that you can actually profile heap usage whilst the application is running without impacting via Heisenberg's uncertainty principle. Transport layer security version 1.3 is now the latest version and it's supported by Java. ZGC is the it's supposedly the zero garbage collector designed for low latency applications with large heaps. It's an experimental one that's not really designed for general use, but it's an interesting thing to have a look at. I would say, because I work for Azul, that we have Zing with C4, which is even better, so use that one instead. Deprecate the Nashorn JavaScript engine, as I said, so that will at some point be removed, probably. And also the PAC 200 tools and API are scheduled for removal at some point in the future as well. New APIs that we get in JDK 11, I think I counted something like 79, if we don't count HTTP and stuff like that. So there's these useful ones here, so you can get a null input stream, a null output stream, a null reader, and a null writer. This is essentially /dev/null for Java, because at the moment you don't have any way to throw away the output that you want from something or to have an input stream which is guaranteed to return 0 bytes. So those are quite interesting. Optional has a new method called isEmpty, which is kind of the opposite of isPresent and tells you if there's a null in your optional. And character now has a toString overloaded method that takes a Unicode code point rather than a character. String has some new methods as well. So there's isBlank, which will tell you if it's a blank string, funnily enough. Lines will return a stream of lines from if you've got a multi-line string, then you get a stream of lines. Repeat will give you a repeat of the string, and then strip will remove all white space from both ends of the string. Strip leading, strip trailing will do the same thing from trailing and leading ones. Strip is like trim, but it uses different way of defining white space. Predicate, this is probably my favorite feature, predicate not, which means that rather than doing something like this, where you say filter S is blank, not, we can just do predicate.not string and then use the method reference is blank. Longer term JDK futures. So I've got a few minutes, so I need to kind of keep moving. There are a number of bigger projects in OpenJDK which are aimed at providing bigger pieces of functionality. So Project Amber is about simplifying the syntax further of the JDK. Project Valhalla is about value types, specialized generics. Project Loom is looking at how to do multi-threading and mapping multiple fibers onto a single thread. Metropolis is rewriting the JVM in Java, and Panama is a replacement for JNI. I'll talk about some of these in a little bit more detail. So Project Amber, some of these things have already gone into JDK 10 and JDK 11, so we'll move on from those. Lambda leftovers is the idea of using a single underscore as a parameter in a lambda expression if you don't use the parameter in the body of the lambda expression. So it's a way of kind of hiding the variable so it's not as obvious and makes it more readable. Raw string literals. These are scheduled to go into JDK 12, and it's the idea that if you want to have multi-line strings, if you want to have strange characters which would normally require an escape character in a string, you can use a single backquote. So now we can do single backquote, and we can have C colon /users /Simon. Great, until you say, hang on, if everything after that is treated as a string until we get the next backquote, what if I want a backquote in my string? And they've thought of that. So you can use one or more backquotes. So you could have backquote, 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 a string with a backquote, backquote in it, backquote, backquote, backquote. And then it will work. Pattern matching. This is the idea of extending switch statements so that rather than having cases which are purely strings or integers or enumerations, i.e. values, we can now do a switch on a type. And that way you can say, okay, case integer, case byte, case long. This avoids the whole problem that you would normally have of having a number of if-else clauses and using instance of and getting quite a lot of code. So it's a nicer way of being able to do that. Switch expressions. This is scheduled for JDK 12, and I quite like this because this is a very typical way of using a switch statement, which is that we want to switch on a value and then set another value. Here we've got the days of the week, and we're looking at how many letters there are in each day of the week. So obviously each case or group of cases is going to set the number of letters to a value. But as you can see, there's a lot of code. There's a lot of lines in this for what we're trying to do. With switch expressions, this code will be radically simplified. So now what we'll do is we'll say that the switch expression can return a value. So we won't make one assignment of num letters to the result of the switch statement. Within the switch statement, we have now, amazingly, comma-separated values for our cases. So we don't have to have a separate line for each. This is something that's only taken 23 years to get to. And we'll borrow some of the syntax from lambda expressions to say that the body of the expression, the return value, is what's on the right-hand side of the arrow. So 6, 7, 8, 9, and we can also throw an exception if we need to, because there may be situations where that makes sense. So it's much simpler in terms of the code. Project Valhalla, as I said, is about value types. It's about how we deal with primitives versus object representation. Primitives were included in Java at the beginning because of performance. If we treated everything as an object, it just didn't give good enough performance. Now we don't really need that, but we're stuck with primitives, and we have situations where we might want to use primitives rather than objects. Classic example of that is we can't do an array list of int because it's a primitive. We need an object type, so we have to do array list of integer, which has all the overhead of boxing, unboxing, generating objects, putting them on the heap, needing garbage collection, and so on. So Project Valhalla is about actually being able to do an array list of int rather than integer. It's also about value types where we're essentially saying, okay, create an object, but allow you to code it like a class, but make it work like a primitive. And the most important thing about that is that its value has to be immutable. And that requires some differences because although we have final values in Java, they're not truly final. If you use reflection, you can change a final value. So a value type is one that cannot be changed, regardless of whether you use reflection or whatever. So essentially you can have methods, fields, you can do all of the normal things, but you can't mutate it. You can't change the value, and therefore you can't also subclass it. Project Loom is, like I said, about improving performance of multi-threaded applications. If you want to scale up to literally, tens of thousands, hundreds of thousands, millions of threads, the operating threads are too heavyweight. Fibers will map a number of Java threads to a single operating system thread. And then the JVM itself will handle the scheduling of those fibers on top of the single thread. It's kind of like you have multiple threads on a single process, and the operating system handles the scheduling of those threads. Now what we're doing is taking it to the next level, so you have multiple fibers mapped to a single thread, and the JVM does the scheduling of those on top of the thread. The way that's going to work is essentially using the fork join pool scheduler, which is already there. That seems to work very well. They need to add continuations, which is essentially a stream of execution within the JVM. Less memory and very close to zero overhead for task switching in this. Last one I want to talk about, Project Metropolis. This is essentially rewriting the JVM in Java. And of course, you think about that and you say, well, hang on, if I rewrite the JVM in Java, don't I need a JVM to run my JVM? Well, no, you don't, because you can compile the Java into native instructions rather than bytecodes, and therefore you can just run it that way. This is a much more forward-looking project. It's using things like the Graal compiler project. It's designed to simplify the way that development of the JVM actually happens. There's lots of things that people need to look at, so I wouldn't expect to see this, certainly not in the next couple of releases of Java. Briefly mention Azul's Zulu Java, because we're talking about Java, and, well, this is what we do. So Azul's Zulu Java is where we take OpenJDK, we compile it into a binary distribution, and we then run the TCK on it to guarantee that it is fully conformant with the Java SE standard. We provide those free on our website. If you want commercial support, we can do that as well at a very reasonable price, but we do it for free as well. We support older versions all the way back to JDK 6, 7, 8, 9, 10, and 11, and as soon as we get access to the final TCK, we will do our GA later today, I think. Wider platform support, so we've got 64-bit Windows, Linux, and Mac, and then also 32-bit Windows and Linux. Some people want older versions. For embedded, we've got ARM32, ARM64, and PowerPC. And if you want to, you can try that out from our website. Just to summarize, Java continues to evolve. So we're seeing that Java will develop technically. There's lots of new ideas. There's lots of new features going into new versions of Java. The 6-month release cadence is something which you need to think very carefully about. Which version of the runtime are you going to move your applications to? Remember, long-term support isn't necessarily free long-term support. You need to figure out where are you going to get your JDK from, how are you going to get updates to it, and things like that. Lots of bigger ideas, things like Project Loom, things like Metropolis, and so on. So lots of things still to improve Java further. And as I say, we have our Zulu version of the JDK, which you can download for free, or talk to us about commercial support. So with that, thank you very much.